I, Neodev Ghosh, Peace House Vice Captain.
And I, Vidhan Narayan, Unity House Vice Captain.
Welcome you all to the digital platform of BHIS Council Chronicles.
BHIS has always been innovative with respect to its extracurricular activities.
BHIS Chronicles time and again has been making lovely endeavors to open the arena of widespread knowledge to the vast spectrum of speakers from different fields.
BHIS Student Council takes the initiative with an enterprising and informative session with Ms. Pallavi Agrawal and Mr. Gaurav Sarraf.
Ms. Pallavi Agarwal is a 3D designer, marketing expert, educator, and an avid traveler. She comes with over 10 years of experience and designs STEAM-based education programs for school students. She is also the math whiz and takes care of all the finances of her company.
Mr. Gaurav Sarraf is an in-house existing computer geek and computer engineer. He manages online resources and all media platforms. His center of interest mainly focuses on artificial intelligence, computer security, and robotics. He is also a space enthusiast.
We would like to welcome our guest speakers for the day, Ms. Pallavi Agarwal and Mr. Gaurav Saraf, who will throw light on Rocketry for new generation science education.
Not wasting much time, let's ask our guest speakers to talk magniloquently on this topic, which will lead us to give approbation for their magnificent work.
Hello everyone here. Happy to be on board. Happy to be here and talk about a robotics and a rocketry program. Is Pallavi here?
Yep, I'm here.
Hi. So today we'll give you a brief introduction of our company and talk about a rocketry program. Pallavi, do you want to take over?
Yep. Hi guys, good evening. So Atlantis was founded back in 2007, and I will take you through a brief of the relationship we have had with Billabong School. We have been working with Billabong since 2011, and we pretty much closed 10 years next year. And we've had a very successful relationship with Billabong, and we have been doing all kinds of programs, be it an international trip or domestic programs or competitions. And Atlantis was founded in 2007 when we started with our international trips. Then in 2010, we started doing programs in school. And we also had other programs called domestic travel programs, which had science and astronomy camps. Atlantis basically focuses on STEAM-based educational programs. Next slide, please, Gaurav. And our primary mission is to nurture young minds through innovative educational solutions. We have 5 different ventures at the moment. One is Atlantis, then the other one is Space Trek. We have Think Robotics, Space Settlement Design Competitions, and Astro Trek. Slowly and gradually, I will take you through all the programs. Why Atlantis? So Atlantis has been providing world-class learning experience to all the students following multidisciplinary STEAM-based educational programs. We design and custom makes program as per the school's requirements. And Space Tech, which is our sister concern in Kennedy Space Center, Florida, which has been running programs since 2013. And we have exclusive access to vast knowledge because we have close association with Boeing and NASA. Next slide, please. So yes, as mentioned earlier, we have exclusive partners and associations with Boeing, NASA, Space Trek, and then we have Pennsylvania State Government. We work with Pennsylvania State Government to do educational programs, and we take students for university trips, wherein the schools and students understand how the admission processes in US work. Next slide. So our foundation seed of this company was sown by Mr. Abhishek Agrawal, who is the founder director of this company. He was the first ever Indian, and his team was the first ever Indian team to win the Space Settlement Design Competition. This competition was founded in 1983 by Miss Anita Gale and Dr. Richard Edwards. And this competition ever since has been hosted in the US as finals. And we have been hosting Asian Regional since 2004. This year, we have the 17th competition going on, and Billabong is again one of the teams in that competition who have been qualified as quarterfinalists. So congratulations to the team who has participated and qualified this year. So the idea of this competition, I will let Gaurav take over from here.
Yeah, so what is ARSDC about? ARSDC is a competition where students build a safe space settlement for humans to live in different planets. So it doesn't have to be just planets, but also in orbit. So this year's scenario is students will be building a tourist settlement, which will be moving between Earth and Mars. So just imagine you have a population about 15,000 people, and what are the facilities required to home 15,000 people? You need to think about the electricity. You need to think about the food, the waste management, the housing, and everything, right? So kids actually, high school students designed the whole settlement for the whole for all 10,000 people in space. And you can see examples of few of the settlements, which is there on the left. On the left side, you can see there's something called O'Neill's torus, where for you need to generate artificial gravity in space, because without gravity, life cannot survive. So you need something like a wheel or a donut, which is continuously rotating, and that creates artificial gravity. So these are the few of the settlements which have been previously made by our students. These are a few of the pictures from last time's competition, and Abhishek Bhaiya, who's holding the trophy. The trophy is actually it's a meteorite, and it is a rolling trophy, and yes, it is given to the winning team, and your name's written on the trophy itself every single year. These are a few more pictures with our CEOs from Boeing, NASA, and other space organizations mentoring the students, and various technical sessions going on. Right in the middle, you can see our founder, Anita Gale. She judges the competition, every single competition which happens in India, which includes the Indian nationals as well as the Asian semifinals. On the right side, you can see the judges' deliberation, where they're deciding who should win. And on the left side, you can see team presentation pictures. And on the right side bottom, you will see the Indian team which won last year, and they're proud to host the Indian flag there. These are the few of the schools which have participated with us in the past. Of course, Billabong is an important team which has been participating frequently, and this year they've qualified as well. So hope to see you guys next week in the competition. Right. So I would also like to talk about Think Robotics, our new venture. Think Robotics is a rapid prototyping company which was established in early 2018, and since then we strive hard to deliver engineering related products. So we take your ideas or projects which you're working on and make them market viable products, market ready products, so you can actually create this as a viable business. We offer multiple services as PCB layout design, electronics development, 3D printing. So anything in your technical endeavor can be designed and can be handled by Think Robotics. We also do PCB manufacturing and 3D modeling. So if you want to build something, if you do not have the expertise to actually 3D model something, we can do that for you. All of this happens in-house with our expert engineering team. Think Robotics is also the exclusive partner for Auto DIY. This is a leading robotics brand in Europe, and we are proud to have Auto on board. We will be launching our three versions of Auto in India, which are available on our website in workshops, with workshops and without workshops. So these are few of our clients which have worked with us before. Yeah, Space Tech in Atlantis. Pallavi, you want to take over?
Yes, absolutely. So yes, coming on to Space Tech. SpaceTech is basically a company which designs and develops education programs for students across the globe. And we have students from more than 20 countries who have already participated in our programs. It has three different kind of programs, which are robotics, rocketry, and near space investigation. Robotics mainly focuses on designing a robot, which is 3D printed in our own labs, and it has various kind of machines and motors attached to it, and the students are made to design their own robot and then launch it on a mock lunar surface. Because this surface that is given to them is mock lunar, so it has a camera, the robot has a camera attached to it, and the students are supposed to be looking through the camera from their computer screens and achieve the assigned task given to them. And they're working in different teams, so the students achieving the maximum number of targets get the winning medals. So for talking about more of its sciences, we will have Gaurav do it in just a while. And coming on to the next program, which is rocketry. As our subject says, rocket sciences for new generation. So coming on to the rocketry program. So for rocketry, this is again a science program, and it has wherein you design your rockets. You have physics and science involved in it. You learn about the gravitational force and other Newton's laws of motions, and then launch your rockets. And it is done over a period of 3 days at NASA's Kennedy Space Center. And the next program, Gaurav? So these are various pictures of students doing their program and launching their rockets. We have two different ways of launching the rockets. One is when you are launching in the field, which is the final test run that we do. And before that, we do it inside the classroom itself, wherein we have different machine setup, which is a closed cabin, closed box basically of plastic, wherein you launch your rocket, where you understand the physics behind it. Next slide. Then coming on to the near space investigation program. This program basically is wherein you design your own weather balloon probe, which goes up to 1 lakh feet high. And through it, you have the hardware involved in this program are flight computer, altimeter, Arduino temperature sensor, and cameras. With the camera attached to the payload, you note down the readings of the atmosphere, you look at the Earth's temperature, and various other things. And you also learn the techniques to maintain and test various subsystems using a series of checklists while testing all the components for the final launch. Gaurav, would you want to go behind the sciences of these programs?
Yeah, so why don't you go to finish the presentation, and I will go through the whole thing again with the science.
Okay, so then we move on to the next slide. So these are different wherein we have safety controller, we have systems check, we have flight controller unit. And just before the launch, we do a photo shoot and we are getting up all to set up. So these are the pictures of that. Next slide. Coming on to the Atlantis programs that we have been doing, we have domestic camps as well, because not all students can afford to go to the US. And even if they can, they want something hands-on, they want some hands-on activities in school itself. So which is why we designed this program called Quantum Discovery Workshops, wherein we do all kind of science activities hands-on. The ones that you learn in your textbooks, we try to bring them practically to you, just so that you don't have to memorize everything, but learn by doing. So the policy that we follow is learn by doing it yourself. Like we say, DIY. So Quantum Discovery Workshop has different activities like soda straw rocket launch, wherein you understand the physics behind launching a rocket, and it is a paper activity. Then we have electromagnetic spectrum, wherein you understand how light travels and how is a spectrum formed. Then we have rocketry launch again. Next slide. Coming on to AstroTrek. In AstroTrek, it is basically a science and astronomy development camp wherein you also have personal development activities. In astronomy, we do night astronomy and day astronomy. So when we are talking about day astronomy, we learn about how sun travels. Basically, the sun does not travel, it is stationary. But then definitely Earth keeps rotating and revolving. So how sun position changes every day and every hour. Then we have, we even note down sunspots. We have done that activity quite a number of times with Billabong. So I'm sure most of the students participating right now must be aware about it. So yes, we have solar astronomy, then we have night astronomy camps, then we have trekking, through which you understand about different activities, and then you have Burma bridge building, then you have you do even optics and light activities within the classroom, which we have at the campsite. So we have been featured in a few media. So these are all about that. We have been featured at Education Times, then with Times of India, Forbes magazine. Bloomberg University is a university in Pennsylvania where we have been working with. We have been working with for quite a few years now. So in their magazine as well. Thank you so much for watching our presentation. Now Gaurav will take you over the sciences of all the other activities that we have.
Okay, so now that we have all the formal stuff out, coming back to all the science. So Space Trek and Atlantis primarily design science programs, right? So what is the focus of these programs? What are we trying to actually teach you? What will you actually learn? And is it just boring science or is it something cool? Okay, so to start off, first we do mission robotics. Mission robotics is a robotics planning platform where students not only just play with the robots, but actually make everything on their own. So if you have to, if I give you a task of to design a robot, how do you do it? What would be the computer running that? What would be the motors? What would be the camera? So many questions, right? So we try to simplify the process for you, give you the basic elements so you can do the fun stuff and learn the important science behind it. So we have used worked quite a lot, and we have played with remote control cars, right, as kids. But this takes it a step further. This is not only remote control, but it is autonomous. What do I mean by autonomous? That you program your path beforehand, before you actually start and let the robot go. So autonomy can be done in two ways. Either it can be pre-planned, that is semi-autonomous, or it can make decisions on its own. So over here, you're going to be doing both. So first thing is you will build a robot which can do basic stuff like avoid obstacles, follow a line, figure out obstructions on its way, all of those stuff. And second, then we come to more complicated systems like a robotic arm, a wireless remote camera, and then RFID detectors. So let me just go through a little bit in detail of all of these three components. First is robotic arm. Since you see there's a camera on board, you can do a lot of stuff with it. You can do retrieving. You can retrieve objects. You can actually go and remote sense the location. Since we actually can't go to Mars, we simulate a Mars solution, a Mars surface. On that, there will be some sort of a task where you have to pick up objects from the Mars surface that you will be doing using the wireless camera as well as a robotic arm. So the robotic arm can extend out to the surface and pick up components, which is given in the task. Next is the wireless camera. So you will not only learn how to use the camera, but also actually install it, how to actually set up a network communication system between your computer and your rover. So we usually use a computer called a Raspberry Pi. Raspberry Pi is actually strong enough to do and handle all of these small nitty-gritties of the robot. Yeah. So I'm sure many of you might already have experience with camera and Raspberry Pi. But the interesting part is how do you get it to connect to your computer and then control it from there? So we teach you all of that. Radio frequency identifier detectors. So in a real life scenario, what happens is how do you navigate through a specific situation? You're going to use GPS, right? So GPS is not very accurate on a smaller scale, and it's not it does not work really well indoors. So what we have done is we have built up a radio frequency system which triangulates your location in the interior of the Mars simulation. So with this, what happens is you're not only learning about how actual navigation works, but you're also fiddling with radio frequencies and fine tuning your radio frequencies to best suit your robot's needs. So all of these combined builds a really strong robot which can help you navigate through difficult terrain, and not just navigate through difficult terrain, but actually build a real-time robot, a rover which is used in industry by companies like NASA and Blue Origin. Just for information, Blue Origin is the space company hosted by Jeff Bezos. Okay, so these are the few pictures from the class. You can see kids are building a basic line following robot on the left. Then they're trying to program their rovers, and on the right side, these are actually my class friends. So they are building a robotic arm, and they're figuring out what is the best solution to actually go and pick up some object on the ground. And then you have an expert who's helping the kids and explaining how things work. And then this is the certificate ceremony. Okay, so now coming to rocketry. So in the recent years, you have seen ISRO being very, very competitive in the world space scenario right now, right? So how do you think this is happening? This is all the research ISRO has done over the past years, and now they are at a situation where they are actually able to send the robots out at the most efficient and the cheapest way possible. So there's a lot of research which goes into this, and our water rocketry program gives you that. So we don't just teach you about how rockets function, but we also give you the thermodynamics and all the other pressure systems which are required to run a robot. Of course, we cannot give you a fuel-based robot because that's way too risky. So what we do is we just take a normal Coke bottle, 2 liters Coke bottle, and fill it with water and air pressure. So the pressure acts as fuel and then pushes the rocket further. If you see carefully, there are antennas as well as cones as well as fins on the rocket. So they have a specific purpose to that. First of all, the cone makes the rocket more aerodynamic. It helps it fly more efficiently in its path. The fins help it make it steady on its path. So if without the fins, the rocket is not very stable, it keeps wobbling, but with the fins, the rocket path becomes much more stable. Coming back to antennas, that's the fun part. So on these rockets, we actually send a computer. It's a small Arduino-based system which hosts a lot of data and collects the whole flight data, or it's called the flight telemetry data, and keeps it on board and sends it to us. So our focus is not just to teach you how to just take the robot onto the field and launch it, but actually even retrieve the rocket and redo and go through the process again. So you need to be able to locate the rocket, and the flight computer helps you do that. So have you guys heard about machine learning? Yeah. So someone said yes, and yeah. So machine learning is like a big part right now, big industry trend right now. It is a very small part of artificial intelligence. So for AI and for machine learning to work, you need a lot of data. And how do you think weather stations calculate the data? So the weather stations get a lot of data from these rockets and these weather balloons, and this data is set into a machine learning model, and then the model is able to figure out how's the weather going to be. So all of this data can be used by you guys to actually do your computation and figure out some key insights. So what you're doing from the rocket is just collecting data, but from the data you have to convert the data into useful information, and then the useful information becomes key insights. With that, you're able to take multiple decisions. So a big part of water rocketry is the computing and the data collection, which is important for not just water rocketry, but any experiment in general. You would have seen that you guys, whenever you go to your science labs, chemistry labs, and physics labs, a big part of it is recording the data and making the lab records, right? So this is the reason why, because only if you record the data, you'll be able to make connections with different data points and generate insights. So these are few pictures of the water rocket. On the first, you can see the water rocket being launched. On the left side bottom, you can see a rocket still in designing. If you can see carefully on the right below the cone, there's a yellow color thingy. That's the computer and that's the eject mechanism. We also have a parachute on the rocket itself. So when it drops down, it does not damage the damage the rocket. Sorry. So in the center picture, you can see a water rocket on its launcher. But we have done something fancy, and some kids wanted to combine the two projects. So they have gone ahead and taken the robot and tried to mess around with the water rocket. And on the right side, you can see flight director. He's doing the final checks and giving instructions. So we do realize that water rocketry is difficult because you can't keep launching a rocket again and again. So we have designed an apparatus for that, where you will have a specific enclosing system which can be used to test your rockets over and over again. So just to give you more idea about our water rocketry program, why don't I show you a video? Just give me a second. So yeah, as you guys can see, is my screen still visible?
No, sir, you stopped screen sharing.
Yes.
Okay. Let me go back to the video 1 second. So this is the test apparatus I was talking to you about. So you can see various rockets which are being tested. This is called beta. This is a test apparatus where you can't just where you don't just test the bottle's integrity, but also the force which is required to launch the rocket. It does not just randomly put pressure into the rocket, but it also measures the exact amount of pressure which is required for a specific height requirement. On the top, you can see this is a really cool setup, as everything is built in house, and there's a pressurizing system here, and on the top to control the force, it's carbon plated, so it can take the carbon fiber is actually one of the strongest material out there. So carbon fiber is able to take all the pressure which comes from the rocket. Sorry. You can see the rocket in action here and goes quite far away. In my expectation, I think it easily goes up to 150 feet up in the sky. Okay, so just for information, the rocket is available on our website. And yeah, let me come back to our presentation. So yes, near space investigation. So water rockets are limited. They do not go very high. The maximum height is, I think, 150 feet. Beyond that, you need something which is autonomous and something which can be retrieved later on, right? So what we do is we have come up with a program called Near Space Investigation. Excuse me. So this is basically a weather balloon which goes 100,000 feet. This is right near the edge of space. This is where the air becomes very thin, and this is the distinction line between the air and space and space in general. So again, the payload is very important for any of these missions in space. So this mission has a computer which is based out of Arduino, and this measures multiple different kinds of data like humidity, pressure, temperature, velocity, and altitude throughout the flight. So what this gives is, this gives you a really good idea of how uh, how it differs, the situation on Earth and how the situation near space is very different, and how you can design your components which can survive the harsh weather and harsh scenarios in near space. So these are a few of the pictures. You can see in the center picture, that's the payload. It has all the sensors. It has enough power to power all the sensors, the computer on board, and the storing information. This is them launching the robot. Sorry, the space balloon. Okay, I think quantum discovery you guys have already done. Billabong has been doing that quite frequently. There's not a lot to explain here. But yeah, are we doing questions and answers?
Yes, sir.
Yes, I'm open to questions now. If you guys have any questions, please go ahead.
Yes, sir, there are.
There's a question from Agastya. He's asking that which software is to be used to design robots, and is Altium Designer enough?
Okay, so Altium Designer isn't exactly enough, but what we do is we concentrate on the tools which are used in the industry. So what are these tools? So first is Robot OS. It is a complicated simulation software which lets you simulate a robot in software. So the actual product which comes out is solid, and is for sure it works. And for all computer vision stuff and computer related camera related stuff, we use a software called OpenCV. OpenCV is a Python library. Actually, it can be done in any subject, any programming language. So it is a library which helps you do visual recognition, and all of those stuff. So with RFID navigation, that is again a custom software solution that's not openly available, and it's not used by the public because it's available only in a very small space. But yeah, if you're building a GPS based robot, you can use something called ArdioPilot. So ArdioPilot is a very stable system which lets you build robots and drones and all of those stuff. Okay, next question.
Sir, thank you, sir. So the next question is from Agastya. Is Rocket a robot? ROV and RMS. Sir, you're muted.
Okay, so it depends on how do you define a robot. So robot is anything which can take decisions on its own, right? So if you have a rocket which can take decisions on its own and can stir in space during the flight, then it is smart. You can call it a robot. But if it is a pre-planned thing, then you wouldn't call it a robot because it's just a pre-planned system, and it's just following instructions which is already hard-coded. Say for example, if you have a drone, right? So the lines between a drone and a robot and artificial intelligence is quite blurred here. As if you have a robot, fine. If you have a drone, it can be controlled by a remote. 90% of the time, it is actually controlled by a remote. But then, what happens when the robot is following you? So is that artificial intelligence? Is that a robot? That's up to you. But yeah, robot is something which can take instructions and look at the scenario, take feedback from its environment, and then act accordingly. So a drone in its autonomous mode is a robot. Same goes with rockets.
Sir, Agastya has another question. How to make a robot with a circuit diagram and design? do we need to follow morphological analysis to configure the space matrix?
No, I think the question is actually quite wide here. So what you need to do is to make a robot, you don't have to actually design the circuits involved. What you need to do is use something called a computer, which can be Raspberry Pi or an Arduino, right? So these systems are more than enough, are capable enough to make any sort of robot which you might plan. So there's a computer called Raspberry Pi. Raspberry Pi lets you do a lot of computation, and not just computation like and computation locally, but also sends data to your other base stations. And of course, you can also connect various sensors, various components to make the robot smart. Okay, I can see the questions here. Sir, are there any classes conducted by Atlantis for this? Yes, as I said earlier, we do have for as a beginner level we do have Auto. Auto is a small robot which can dance. It can listen to your instructions. It can follow lines. It can sing and do a lot of more stuff. So this robot comes in 3 different levels: the Auto Baby, Auto Plus, and Auto Pro. And Auto Pro comes with six servos. Auto Baby and Plus comes with 4 servos, and these can be controlled by a computer or with your phone. So yes, these classes will be conducted, and yeah, we did have a presentation with Billabong, I think about 2 weeks ago. So yeah, you can sign up for these classes if you're interested. And all of these components, robots, everything is available on a website. It's thinkrobotics.in. I'll put it in the chat.
I am putting that in, Gaurav.
Okay, so I just sent a link. You can use that link to go to the website and check out the robot, look at the specifications, and sign up for whichever robot you're interested with. Okay, next question. Do you guys have any questions regarding cybersecurity, artificial intelligence, anything?
So everyone, please ask questions.
Sir, I have a question.
Yeah.
Sir, do you think that, I've heard conspiracy theories that Facebook, Instagram, Apple, Google, they are all stealing your data and then they're providing all of that to FBI and, the United States government.
Mm-hmm.
Like they can access our camera anytime they want. Is that all true?
Okay, so what do you think Google does? Vedant, can you give me what do you think Google's main business is?
So dealing with the United States government,
No.
instead of providing us the services, they mostly deal with the United States government for data.
Okay, no, that's actually not the
They're
scenario.
collecting data.
No, again, that's the part of Google's job, but that's not what Google does. Those are conspiracy theories that they're sending all your data to the US government, but that's not how it works. And they do not collect data just to send stuff to the United States government. But yes, Google clearly, openly accepts the fact that they are a data company. So data is the new oil. Google is very famous saying this. In our olden scenario, even in the current scenario, people say that whoever has oil is rich, right? That's been the norm as along. But now that's not the scenario. The company which has a lot of data is the richest company in the world, and Google collects a lot of data to give you the right services. So if you see suggestions of recipes you were just talking about, they're probably collecting your data. Of course, the ways of collecting data is not black and white. They do some gray area stuff as well, where they're recording your microphone data without letting you know. But still, it's all of this data is encrypted and it's not shared with anyone. That's what Google says. And yeah, so only if you have data, you have all of these fancy services which you rely on. How do you think Google Maps work? Google Maps collects data from every single Maps user, and that's how accurate traffic analysis and traffic prediction is enabled right here. And it's not just Google. Every company does it. Instagram, Facebook is the same company, and even companies which you might not think, and which you might not think the data is important, they actually capture a lot of data. A good example of this is take these grocery services like Big Basket, or what are the famous grocery services like Grocers. They monitor all of your data, they monitor your ordering habits, and change their offerings accordingly. So yes, did I answer your question? This is actually a very open-ended question.
Yeah. So, sir, then there is a
There are
question.
more
That's
questions.
there.
Okay.
How can you build a massive AI-powered robot at home?
So technically speaking, it's fairly easy. What do you actually mean by AI powered? AI powered can be very basic, which can play tic tac toe with you, or you can do something really fancy by collecting a lot of data from different sorts of sensors. So currently, one of my research teams at IISc was working on a robot which took data not just from one sensor, but 11 different sensors. So this is a robot which took data from cameras, from ultrasonic sensors, from infrared sensors, from LiDAR sensors, from sonar sensors. All of these are relying on the basic same sort of sciences. But yeah, so they're collecting data from all of these different sensors, and they pass it to a model called it's called a multi-sensor fusion model using carbon filters. So with that, they're able to make complicated decisions of how to actually steer the robot in a difficult scenario. So talking about coming back to massive AI powered robot. So what an AI system technically needs is a lot of data. So if you have the data, you can create a very fancy robot. So we are currently working on a AI system which can be run on Auto itself. So you give voice instructions to Auto, and Auto will follow those voice instructions. Whether that is following, walking forward, coming backward, dancing, or singing, whatever it is. Okay, and yeah, so a big part of AI is also its training period. So every single AI system needs training. So only if you train the computer, the machine learns from the old data to generate new instances, and it can handle new scenarios, right? So yes, if you have the hardware, if you have the data, you can do it. Next question.
Sir, Vanya Jindal has asked a question.
Mhm.
Can robots be sometimes dangerous?
Of course, robots can be extremely dangerous if not handled well. But in our scenario, we have not come up with a robot which is extremely dangerous to us. The maximum we have done is we have put AI on a self-driving car. That might cause accidents, which you guys might follow on news. I think even last week one Tesla car just blew up because the AI did not recognize the eight does not recognize the three properly. So what it did was its camera misunderstood a 35 kilometers per hour speed limit as an 85 kilometers per hour speed limit, and because of that, there was a huge accident. So yes, AI can be dangerous, and not to mention, if you guys have heard about something called GPT-3. GPT-3, I can put it on chat. So GPT-3 is like a very comprehensive, a very, very massive AI system, which was designed by OpenAI. It's again a Tesla sister company. So this AI system is said to be extremely complicated, extremely comprehensive, and at some level dangerous, because it is so convincing with the text it generates that you cannot differentiate from a text which is written by the robot and written by humans. So in that way, yes, it can be dangerous. Okay, next question. I think there are too many questions. Can someone please help me with the questions?
Yeah. Sure, sir. So there is a question from Samrid that are robots only made of metal or are they made of any other material too?
No, if you think about AI, right? AI right now is currently only in software form. So the definition of robot is actually not as easy to define, because robot can be anything which takes information from its environment and comes up with a decision, right? So a robot can be an AI system. A robot can be a robot with a rover with its own computation. So it does not just have to be metal.
Sir, there's a question from Krishnansh. Sir, why does Auto have three names? Auto Baby, Auto, and Auto Pro.
Okay, so Auto has three versions because it concentrates on three different age groups. Auto Baby is to just teach the kids the basic stuff, the basic computer, how to program it, how to actually use the sensors, use the computer. On the other hand, Auto Plus adds a level of difficulty with adding Bluetooth and adding various other features, including another sensor. So it adds a level of complexity where you're able to take data from not just one sensor but multiple sensors. And Auto Pro, on the other hand, it makes it even more complicated as you're dealing with not just 4 servos but 6 servos at the same time. So how the electronics has to work in collaboration with each other, how the sensor has to take the data and send the data to the servers, instructions to the servers. So yes, there are three different versions just because of that. And very soon we will also be launching our wheels version, so Auto with wheels.
Sir, Agastya has a question. Can we configure a Storm rocket for space?
Storm rocket for space, I don't think so. It's not powerful enough. For anything for it to go to space, it needs a lot of energy, and I'm pretty sure storm rockets do not have so much energy.
Thank you, sir.
You're welcome.
Sir, then regarding cybersecurity,
Yeah.
so sir, the next war that will be fought, I don't think so. It should be a physical war. Like, most of the time we're on the internet, so I guess it should be a war regarding internet conspiracy and attacking user bases, databases of people.
Okay,
So
I get a question. Thank
yeah,
you. This is a very, very huge topic, and this is probably going to be my thesis topic for my master's. So this is extremely true. I'm really surprised that kids of your age actually figure this out, and you have taken this notice that real wars in the future are not going to be fought on battlegrounds, but it's going to be cyber wars, right? So this is extremely true. It cannot be, we are living in a very exciting time right now because this is our generation will be the first generation to actually see a war which is happening on the internet. God forbid, I do not want this to happen, but yes, it's quite an interesting scenario where every single country is trying to build a cyber arsenal where they will be attacking other companies' infrastructure. Now the problem here is that every single country's system is now connected to the internet, right? So if you think about it, I don't know about Kanpur, but in Bangalore, where I live, they have connected the whole city's traffic cameras to the internet. They collect data autonomously. If you're not wearing a helmet, the camera is smart enough to actually figure out your license plate number and send you a ticket challan to your house. So all of this data, all of these information, all of this equipment is openly available on the internet. It's not openly available. What do I mean by openly available? Normal people will not be able to actually take advantage of this, but a cybersecurity expert, on the other hand, does realize that these systems are always faulty. Currently, we are using a system called Zoom. This meeting is happening on Zoom, and Zoom just a few months ago was extremely famous for its various security issues, right? So this is definitely true that the next war is going to be a cyber war, next big war. A good example of this is the attacks which happened on the power stations in somewhere in Maharashtra. I forget the exact name, but yeah. So some North Korean hackers try to hack the power plant and steal data. So this is happening quite often in real time. And another very good example and good scenario, and I would say backlash of this situation right now is every single country is trying to build their own internet. So if you might know, China does not actually connect to the internet like all the other countries do. So they have something called a firewall. So the firewall restricts all the data which is going in and going out. And recently, Russia also designed something like this, and they were successful. So to stop all of these attacks, countries are going to be taking this step where they will be deploying many of these firewalls to protect their country's infrastructure. So yes, this is a very good question. Next question. I see two hands up.
Yes.
Yes,
Vaibhav and Ran, please type your
questions in
question
the
in
box.
the chat box. You will not be able to unmute yourself. And please lower your hands.
So Augusta has a question. Can't we design an AI robot to identify and punish hackers?
Sorry.
So can't we design an AI robot to identify and punish hackers?
Okay. So I don't know about punishing hackers, but yes, you can design AI which is going to detect hackers. So I have authored 3 research papers, and all of my research is regarding this topic: how we can use AI to actually stop hacking scenarios. My first system was how to use artificial intelligence to detect spam and to spot malicious code or viruses from emails. My second AI system was to look at the network traffic and identify which packet in the network traffic can actually be a hacking attempt. So this is another system, and my third system was hiding data efficiently, you know, efficiently in other data types. So if you guys are interested, I can show you the research paper. But yeah, I would appreciate if the questions are more strict, because again these are very open-ended questions.
So there is a question from Vaibhav.
Yeah, go
What
ahead.
is a multiple?
I'm sorry, I don't think I understand that.
Vaibhav, if you could just clarify your question once more. Sir, until then, Sir Rayan has a question.
Yeah.
So what does Auto Pro do that it has attracted so many customers?
Okay. So AutoPro is not just about teaching robotics, but it's actually a platform which can let you do a lot more stuff, right? So this AutoPro gives you a platform where it's totally up to your creativity, and it's totally up to you. You can add as many sensors as you want. You can actually even give it different shapes. So if you the auto which you see on the screen right now, this looks like a square, it looks like a cube. But if you want your robot to be a cylinder in shape, if you want your robot to be circular in shape, all of that is possible. So you can design these robots, and you can design these robots and you can order it for 3D printing from our website. We will 3D print this and we will send it to you. And this is why Auto has become a very famous platform, because it's totally up to your creativity, and it's totally up to you for what you want to do, what sensors you want to add, what features you want to add, how you want to make the robot interact with you. It has a screen on its belly, so what are the expressions you want to show? All of those things can be done. So yeah, that's the reason why it's become this famous. Yes, any questions?
So can a supercomputer, so this is my question. So can a supercomputer, predict the next war?
Okay,
Like,
so
is it
what
advanced?
you're talking about is an AI system which is closer to a singularity. So that's not going to happen for at least 50 to 80 years. So even though I do understand the cutting edge of AI systems in the world right now, but we are not at a scenario where AI can actually take so much data, analyze so much data in a realistic hardware setup, and predict something like this. It's just too complicated. I don't see this. At least I don't think in our generation, in our lifetime, we will be able to see this.
Sir, in our generation, is it probable for a war with the robots or the AI?
No, that's not going to happen either. So the most complicated robot, which is physical, is Spot. It's by Boston Dynamics. It's yellow in color. Do you guys know what Spot? Yeah. So if you want, I can pull up a
It's a
picture.
dog-like robot.
Yeah. So Spot, let me just pull up a picture. So I hope you guys can see my screen now.
Yes, sir.
Yeah. So this is the most complicated and the most comprehensive robot we have ever built, technically speaking, which is out in the market and openly available. So there are more robots which look like humans, but these robots are not even close to, taking their own calls. And this is the only robot which is open on the market, and it can take its own decisions and react accordingly. And this robot can barely run at 30 kilometers per hour. So even kids can outrun it. So you will not see war robots anytime soon.
So that means that we are safe from Terminators right now.
Yes, that's quite far away.
Sir, then there is a question from Saiba. So what are AI neural networks? AI neural.
Okay, so again, let me just pull up a picture. Just a second. Okay, so I hope you guys can see my screen now. So what are neural networks? Neural networks are part of machine learning. So you can see there's a bigger part called AI, and under AI there are many different types of AIs. A part which is famous right now, it's called machine learning. And under machine learning, you have a system called neural networks. So what are neural networks? Neural networks are basic building blocks of any new AI system, and they are designed on humans, on how humans think and how human brain works. So if you've seen a human neuron, how does that look? It has a central computing system, and it has various I think it's called tentrons. I'm not sure. Yeah, so it has various nerve endings which connect to other such nodes, computation units, and these are like I think human brain has like 100 billion of these. So using all of these, humans are able to do complicated tasks. This is not just able to it does not just enable humans to make decisions, but it also helps us to learn and remember stuff, right? So a basic building scenario of a basic setup of a neural network is like this. There are 4 different layers. The layers can increase based on based on how complicated the AI system is. First is the input layer. Input layer is basically one neuron. All of these neurons, all of these nodes take in data. So what is this data? Data, like I said, any machine learning model, any AI system needs a lot of data. So that data is sent to this input layer. Then this input layer computes, does a little bit of computation, and updates something called weights. Weights are the basic information which is being sent. And each node connects to every other node in the process and throughout the network. And with that, you can see the number of layers and number of connections keep increasing. And with that, it's able to make extremely complicated patterns with the data. And with these complicated patterns, it's able to make extremely complicated decisions. Like if you just take a basic example of if a neural network, if you train a neural network to identify and differentiate between a dog and a cat. So pictures of dogs and cats will be sent through these through the input nodes, and the various computation is done in forms of weights sent to the hidden layer where other layer of combination is data computation is done. So over here it's trying to design like patterns of what is the color, what is the shape of the skull, what is the shape of the ears, and based on that it's able to actually give an output saying that if it's a dog or a cat. So yes, neural network is an extremely complicated system. And a funny part is, I hope you guys know about matrix multiplications, right? Matrices in maths. Have you guys worked on that? Vedant, Neo, if you guys can confirm.
No, sir.
No, sir, not as of now.
No.
Okay, so there's something called matrices and matrix, which you will see in math, and all of that is that's I think we learned it in like 11th or 12th standard, and yeah, so that's the basic building block of neural networks. So yes, I don't want to go more in detail. It's a complicated topic, but yeah. Next question.
Augusta has a question.
Yeah.
How will robots work in case of biological warfare?
I don't understand this question exactly, but the only scenario where I see robots working right now is if there's a war out there, the Indian, any government will send out robots to disassemble like bombs or something like that, bombs or mines, and not more than that. I don't see anything more than that happening in the close future. Yeah, so a big part of AI and robots in warfare right now is the drones. So if I don't know if you guys have seen armed drones. It's used primarily by the US government, and these drones are totally AI driven, and they can take decisions on its own. They relay all the data via satellite link to its base station, and so no one's actually sitting inside the plane or the drone. But these drones and planes can shoot missiles and stuff right in the air. So the US government has been using this for quite some time. So this is the only advancement of robots I see in a biological war.
Sir, Augusta has a question. Is there any AI in SpaceX?
In SpaceX, not really. So they currently have a hard-coded system because that's a requirement by the US government. So yeah, you do not have an AI system which is controlling systems on board because it's just not reliable enough. Like I said, AI is not a proven technology still. So till the near future, I don't see AI being used in space technology. It may be they may collect data and use the data to do some computation via machine learning and AI systems, but to run the rocket, there's no AI for sure. Okay, I think we can do another two questions and let's round it up after that.
If anyone has questions, please ask it right now.
That's about it.
Yes, no questions are coming in.
Okay, great. So it was really fun talking to you guys. I'm totally up for these conversations and random open-ended questions. But yeah, we are limited by time, and yeah.
Sir, there is a question by
So there
Augusta.
is a question from Augusta.
Sir, he's saying, is Mark Zuckerberg a human or an AI?
Yeah, so there's also a conspiracy that Mark Zuckerberg is actually a lizard, is a mutant lizard acting as human. But of course, that's not true. So he is a human.
Sir, I guess he has a follow-up.
Yes.
Exactly. Yeah, exactly. So that's why they say that he's a mutant lizard. Anyway.
Thank you, sir, for the stimulating session, which was indeed a revelation for all of us.
You're welcome.
Our heartfelt gratitude to our founder and CEO, Mrs. Preeti Agrawal, for initiating such talks, which kindles us in the curiosity and deepens our knowledge.
We convey our gratitude to our speakers, Ms. Pallavi Agrawal and Mr. Gaurav Sarraf, for the dynamic talk.
Thank you so much, everyone, to be a part of this BHIS Council Chronicles.
Thank you
We
for
will
having
meet.
us.
We will meet next week on 5th December 2020 at the same time with another guest speaker, Ms. Natasha.
Happy to be here. Thank you. Thank you for having us.
Thank you.
Thank you, sir.
Thank
Thank
you,
you,
sir.
ma'am.
Thank you. Thank you.
Take care, guys. Keep safe.
Thank you.